Hello and welcome into today's class. So we're going to look at a new subtopic within the broad topic of algebraic expressions. And in this particular class, we're going to deal with what we call algebraic fractions. All right. So in the process of trying to solve equations of algebra, you're going to deal with situations where you have to simplify fractions of algebraic terms into a form that becomes more easy to then find solutions of. And so this particular class is going to maybe hopefully help you with that simple skill of being able to express algebraic terms as single fractions. Okay, so that is what the aim of this class is, that other than algebraic terms being able to be written with the coefficients that are whole numbers, all right, we can also express them with coefficients that are made of fractions. Okay, and so when we have a situation where we have a lot of terms that are made of coefficients made up of fractions, then how do we go about that? So that is what we'll be handling as we attempt today to write numerous algebraic expressions as single fractions. Now let's start with this particular example here. So we have in x minus 1 all over 2 plus x plus 2 all over 4 plus x all over 5. And the instruction of this particular problem is that we should express this term as a single fraction. So anyways, just like any other problem that involves fraction, we are going to start by finding the LCM of these fractions, okay, the terms of each of these fractions. So note that the denominator here is 2, the denominator is 4, and the denominator here is 5. So to find the LCM of 2, 4, and 5 will be our first step, and we already know what that is going to be. So the LCM of 2, 4, and 5 is going to be 20. All right, so we're going to start that out by writing it as a single fraction with 20 as our denominator. So we are going to have 20 right down there. Okay, so after this, we are going to multiply the numerators of each of these terms by the dividend of 20 divided by 2. And 20 divided by 4 and 20 divided by 5 respectively. Okay, so in this particular term, we're going to have 20 divided by 2 giving us 10. Okay, 20 divided by 2 giving us 10. So we're going to multiply 10 by the numerator of the first term. So that's going to be 10 into x minus 1. Okay, that's going to be 10 into x minus 1. And for the second term, we're going to take 20 divided by 4. That's going to give us 5. 20 divided by 4 giving us 5. And so we'll multiply 5 plus 5 into the numerator of the second term, which is x plus 2. And for the last term, we'll take 20 divided by 5, 20 divided by 5 giving us 4. And so it will be 4 times the numerator, which is going to be 4x. So we are underway. We are almost solving this particular problem. And so for our next step, we're going to expand what we have in the numerator of our single equation. That is what you're seeing here. So expanding this, we will have 10x. Okay, 10 times x. Then 10 times negative 1, that will give us negative 10. Then we have positive 5 times x, and that is going to give us positive 5x. And then we'll have positive 5 times 2 giving us 10 plus 10. And all that plus 4x. Remember, we are still expressing it as what? We're still expressing it as a fraction. And so to go on and solve for this, we will express this singular, we'll express this single fraction. We'll simplify this, we simplify our numerator by collecting like terms and, simplifying where necessary. Okay, so for our next step, we'll basically have, let me see if I can create space here. So for our next step, we'll basically have 10x plus 5. Okay, they are like terms. 10x plus 5, all right, plus 4. Those are like terms, okay? 10x plus 5 plus 4. And so that's going to give us 10x plus 5 giving us 15, and then 15 plus 4 giving us 19. So we're going to have 19x. Going to have 19x. And for the numerators, we're going to have negative 10 plus 10 giving us 0. So note our final answer will be 19x all over 20. And so we'll leave our answer at that. We leave our answer at 19x plus all over 20. And see you in the next class. Well, sorry to say, I meant to say see you in the next example. All right, so we're going to handle example 2 as we are not yet done with the class. We have one more example, 2 more examples before we are done with this particular recording. All right, so we are having a plus b all over b minus b minus a all over b. And the instruction is that we are supposed to express this particular expression as a single fraction. Remember, the skill of being able to write algebraic fractions as single fractions is going to help you a long way when it comes to solving equations that involves unknowns. All right, so we are going to approach it the same way we approached the first example. Of course, we're going to start by finding the LCM of these algebraic terms. So we're going to look at the denominators. We have b here as the denominator and a as the denominator. So when you're trying to figure out the LCM of these particular denominators that involve variables, always pick each variable and pick the one with the highest power. Okay, always pick. Now that is for LCM, not for GCD. For GCD we pick the one with the lowest power. For LCM we pick the one with the highest power when you're dealing with variables. So we're going to pick each one of these variables, and we're going to pick the ones with the highest power. Unfortunately for us, that's not going to be so hard because we only have 2 variables, and that is b and a, or a and b, however way you want to present it, and all of them have a power of 1. Okay, so we're just going to have it as I've expressed it down there. So for us to then solve for this, we are going to multiply. We're going to multiply each of these numerators by the dividend of ab divided by their denominators. So we're going to have ab divided by b. ab divided by b will give us a. All right, b and b will cancel each other out. So ab divided by b will give us a, and so we'll have a multiplying what? A plus b, which is our numerator. So we'll have a into a plus b right there. I hope that makes sense. And so we'll do the same for the other term as well. So we are going to have ab divided by a. ab divided by a and a will cancel each other out, and that will leave us with b. But in this particular case, I want you to note that we have a negative sign here. So we're going to have that as negative ab, okay? ab divided by a giving us b. So we're going to have it as negative b into b minus a. We're just maintaining whatever we add in our numerator there because we are supposed to expand it and hopefully find okay, hopefully use that to simplify it further. Now, looking at the brackets, because the brackets are not identical, then we can go ahead and, we won't do factorization by grouping. We can just go ahead and expand it and, then simplify where necessary. So basically, we're going to have A times A. All right, A times A. A times A will give us, let me see how much space I have there. Good. So A times A will give us A squared. We're going to add the powers. A has the power of 1 here, and A also have the power of 1 here. So when you multiply these variables, because they are of the same, they're like terms. When you multiply these two variables, that is A and A, we'll just add their powers. So that's going to be A raised to 1 plus A raised to 1. So it's 1 plus 1. And that will give us 2, which is A squared. Okay? So A times A will give us A squared. Then we're going to have A times B. A times B will give us AB. So it's going to be A squared plus AB. You get that? A squared plus AB, as you can see there. Then moving on, we're going to have negative B times B. Negative B times B. The power of B is 1. The power of B is also 1. So basically that means that while you're multiplying, we are going to have 1 plus 1. The powers, going to add the powers together, all right? That is something that we'll tackle in our class on indices, so don't worry. When you get there, maybe if you don't have proper understanding of indices, you will then understand why we are adding the powers. It becomes easier to deal with it that way. So it's going to be negative B squared. That is 1 plus 1 there, giving us B squared. All right, and then finally, we're going to have negative B times negative A. A negative variable times a negative variable. Negative times negative giving us positive. So that's going to be positive AB. Positive AB. And all that all over AB, our LCM that we had earlier. And so I wanted to note that we can then collect like terms and find the solution to this problem. So when we collect our like terms, we are going to have A squared, okay, plus AB, A squared plus AB. And so AB and AB are like terms, okay? So we're going to put them together, okay, plus AB plus AB minus B squared. B squared has no like term, neither does A have a like term. So all that all over AB. All that all over AB. So we can simplify this further, and when we simplify it further, it's basically going to be A squared, all right, that is A as you can see it here, plus AB plus AB. AB plus AB. AB plus AB is going to give us what? AB plus AB is going to give us 2AB. Okay, basically we are adding the coefficient. The coefficient of AB is 1, and the coefficient of ABA is also 1. So 1 plus 1 gives us 2. So that's what we're doing there. So AB plus AB gives us 2AB. We maintain the variables as they are, minus B squared. All that all over AB. And so since there is no further simplification that we can do to this particular equation, we leave our answer at that. So we've expressed it as a singular fraction. Let us handle the last example and conclude our class. Awesome. So we handle things. We are on to the last example of this particular class, and so we are supposed to express this algebraic fraction as a single fraction, and that is 1 all over 3 into a plus b, and 3 all over 8 into a plus b, and plus 5 all over 12a. So just like any other fraction, we're going to start by expressing it in terms of its LCM. And so it's not complicated. As I already said, when you're trying to figure out the LCM of these fractions, pick every variable of the denominator and pick the one with the highest power. So I want you to note that in the first term we have two variables. We're having 3 and a plus b, which is expressed as a single variable. And I want you to note that a plus b is also here in our second term. So basically we'll pick it up as it is, because it doesn't have any power beyond 1. We'll just have it as a plus b. Okay, we'll just have it as a plus b. So we've picked the first variable, which also happens to be in the second. With this here, when you're talking of LCM, we don't really consider commonality. So it doesn't have to be in the third. Yeah, it doesn't have to be in the third. So we'll pick it because it's a variable, and so we pick the one with the lowest power, which of course happens to be a plus b as it is. And then we'll go to the third term. I want you to note that we have a as well, standing on its own as another variable. We'll pick it, and because there's no any other a that we can compare to, so that we pick the one with the highest power, we'll just stick with a as it is. So we already have a into a plus b, and there's something else missing. I want you to note that these denominators, other than having variables, also have coefficients. So in here, our coefficient is 3, our coefficient is 8, our coefficient is 12. So we also have to find the LCM of 3, 8, and 12 on its own and include it in our LCM as you're seeing here. So the LCM of 3, 8, and 12 will be 24. Okay, LCM of 3, 8, and 12 will be 24. And so we'll write 24 right before a. So our LCM will be 24a into a plus b. That is going to be a LCM of this particular expression that you're seeing up there. Nothing complicated. All right. When you're talking of LCM, you pick every term, and also if there's a term that has repeated itself, pick the one with the highest power. So that is what we are talking about there. So we're going to divide each of these denominators by, we're going to divide this LCM by each of these denominators and multiply it by the numerator. Okay, so in this particular case, we're going to have 24a all over a plus b divided by 3 all over a plus b. Okay, I don't know whether I should do any demos, but this should be pretty easy. So a plus b and excuse me, a plus b and a plus b will cancel each other out. Okay, so just a minute. Yes, a plus b and a plus b will cancel each other out. So basically we're going to remain with the 24a divided by 3. Okay, so that's going to be 24 divided by 3, giving us 8a. So that will be 8a times 1, which is just 8a. Okay, 8a times 1, which is just 8a. All right, maybe you can try and take a piece of paper and then do the simplification of these LCMs, the divisions of this LCM on your own, and just figure out if you really understand what I'm talking about here. All right, so on to the second term. We are having 24a all over ab, 24a into ab all over 8. That is 8 into ab. All right, so our ab and a plus b and a plus b will simplify each other out. Okay, so a plus b and a plus b will simplify each other out in that particular scenario. Then we'll be left with the 24a divided by 8. 24a divided by 8. So that is going to be 3a. Okay, that's going to be 3a. And so it will be 3a. Okay, it will be 3a into 3, our numerator. It will be 3a into 3, our numerator. That is the one that you're seeing here. Okay, so ab and ab simplified each other out. Then 24 divided by 8 is 3, 3a. Yeah, so 3a and that's going to be like that. So the final one, the final term, we are having 24a into a plus b divided by 12a. Yeah, 24a into a plus b divided by 12a. So basically that's going to be 24 divided by 12, giving us 2, and a divided by a, cancelling each other out. So that will be 2 into what? 2 into a plus b, and times 5. So basically we are going to have plus 2 into a plus b into 5, which is our numerator up there. Okay, I hope up to there that you're following and it's it's all making sense. I will up there you're following and it's all making sense. It should, man. I mean, it should. If you don't have, if you have no clue what you're talking about, maybe you should drop a comment, and then maybe I can help you, assist you outside of this particular recorded class. But it should all be easy from the explanations that I'm giving. So we're going to expand our numerator and basically try and simplify terms out. All right. Okay. So 8a will just be as it is, 8a. Okay. So we're going to have 8a plus, okay, 8a plus 3a times 3 will give us 9. That is 3 times 3. That will give us 9a. Okay, that will give us 9a plus, all right, so 2 times 5. The numerator times 5 will give us 10. Okay, so that will be 10 into a, giving us 10a plus 10a plus 10 into b, giving us 10b. All right, so it's basically 2 times 5 giving us 10, then 10 into a, 10 into b. All right, 2 times 5 giving us 10, then we multiply 10 by all the terms within the bracket. So that's going to give us 10a and 10b. So when you collect like terms which are already together in this particular scenario, so we don't have to do much work, when you collect like terms, we are going to have 8a plus 9a plus 10a. All right, simplifying each other out, plus 10b all over whatever we have in our denominator there. So that will be 8a plus 10a, giving us 17a. 8a plus 9a, 8a plus 9a will give us 17a. Then 17a plus 10 will give us 27a. So we'll have 27a plus 10b. It has no any log term. So, and that's all over 24a into a plus b. And being that there's no other further way to simplify what we have here, we'll leave our answer at that. Feel free to email me at Nicholas Odhiambo 2015@gmail.com. I'll pin it in the comment section, in the description section, for any further clarification. Thank you.